Oh, I thought I would. Well, there I am. Okay, whatever. All right, I thought I would um, give a little bit of an overview of how I would start to design this assembly. Close this down because there's unbelievable sun coming in here. So, excuse my lack of professionality here. All right. So a lot of people, when I was requesting that you start to immediately work in CAD, what a lot of groups did was just start to make parts. So when you're doing these sort of designs in modern engineering workplace, it all happens in the CAD system, and it happens really in an assembly, okay? So I can't emphasize that enough. Companies spend millions and millions of dollars a year to have common CAD databases that allow them to work concurrently. So you don't have individual people working on different assemblies or separate parts in isolation. A lot of what I saw, several groups just didn't even have an assembly. So they were just standing in separate parts, never working in an assembly. And then when the things went together, it was not so good. So I don't even have any parts as of yet, but I figured I would at least show what I have. I think we can all agree that probably the most the most urgent requirement, let's put it that way. Maybe it's not the most important, but the most urgent requirement is to design the mechanism, the linkage for the suspension such that we have the travel. It articulates the 8 inches up and down, keeps the wheels parallel, doesn't run into anything. Now, I don't know how you do that by just drawing individual parts in isolation. So the only way I know how to do it is to draw the linkage like in a 2D plane, or I guess you can do it in 3D, but I find it much easier to do in 2D. So what I did was immediately in NX, well, first I opened up the assembly and changed some of the colors so I can at least see the different parts. But what I did first was created some datum planes and axes and points. So I created a datum axis going through the wheels, a point, and then a datum plane going right through the center of the vehicle, and a point where the wheel axis intersects that center plane. And then I created a datum plane in the YZ plane that goes through the center line of the wheels as well. And now I'm going to sketch on that plane and fool around with my linkage. So then what I proceeded to do, I changed the colors a little bit, but this is just in sketch mode. So I drew a 4-bar linkage. I constrained it so these points would stay roughly on the main tube. So I got some dimensions here that allow me to move that around. So for example, if I change this to 4 inches, you can see it moves the whole mechanism off. All right. And I put constraints in, or I dimensioned it in such a manner that as I change the angle, like this is where's the angle it finds its position, this one here. If I change that from 90 to 100, you can actually see the mechanism articulate as it would, if it were an actual mechanism. So you could move it around that way. But then what I did actually was then I drew like an upper configuration and a lower configuration. So the upper configuration here is in the dashed green. And the lower configuration is in the dashed blue. And again, I constrained it so, like for example, this line here, this line 14, is representative of this same link here, that's line 5 in my neutral position. So I made this line, I constrained it to be the same length as this line. Likewise, this line is the same length as this line. Again, this line here, line 13, is this link, so I'm constrained those to be the same length. And all the links to be of the same length as in the neutral position. So if I go in and change something, like this, the the length of this link to like, originally I had something more like that. It changes the upper and lower positions. Okay. And what this allows me to do is to kind of tweak through different dimensions and see, what configurations seem reasonable. I can kind of mount them to the frame and can get the needed travel. So these reference dimensions here show the difference between this point in the neutral configuration and the lower configuration and this same point in the upper configuration. So I can tweak the angles and see what they are when there's 8 inches up and 8 inches down. It's not exactly 8, but it's pretty close. It's close enough within about 5 thousandths of an inch. So for a suspension, that's more than within the range of accuracy. And I initially had this link, that's here as line 4. I tried to get this point up inside the frame, but what happened in that situation was that it was just really difficult to get the mechanism to kick down. So I think I have no choice but to move it down here. Okay. But anyway, that's the thought process I go into. So this is the first thing that I've done. So now I would highly recommend doing something like this, getting agreement upon where this should all be. Now I know that at least my design requirement of the travel makes sense, right? And then I can go look at it in context of how it mounts to the frame. So I will probably need to make like a little mounting lug down here, and likewise here and here, and have those go to the frame. Now, as I look at it a little bit more, this link is good. I mean, this point here is good to be straight down, but these, well, I guess I can make them a little inboard, right? If I made them come in inboard, I guess that's what I might have to do, right? But, at this point in time, at least allows me to establish the basics of my suspension kinematics so that it looks plausible. You can work out other disagreements. So this sketch, I think I might go with this sketch, okay? I'm going to save it and keep it in my assembly, but I'm going to use this to design my A-arm parts off of it. I'm not going to just design a lower A-arm and an upper A-arm and try to get them so they roughly fit and then hope the mechanism does what I want it to do. That's kind of designing backwards, okay? So, there are probably other ways one can imagine doing this. Like I mentioned to some people, you could plot out front views and draw on them directly, which would be fine. But, I'm a big fan of letting, they get these wonderful CAE tools at your disposal and exploit the power of them. So this is a good example of using the power of the CAD system to help do the design for you. Okay. All right. I will probably put some other videos up with regard to like how I go about designing other things and looking at some of the analysis. Okay. But again, I think of where you should have been Friday when you handed in the design is to have gotten to a point where you know where your linkage is and to be designing an assembly. Okay. The other thing I do want to mention before I just stop this video is you really should have your group should have a shared Dropbox or Google Drive folder or OneDrive or whatever Windows thing is called, where you can all access the CAD files and work on them again in a parallel manner, not where everybody has their own copy, and then as you change it, nobody else knows what changes you're making, so there's no way they can see any issues that come about from the changes you do, or you can't see any issues that you might have from the changes that other people do. Okay, so I would highly recommend that. And we've done very complicated assemblies with NX on Dropbox and Google Drive, and both of them work quite fine. Okay, all right, I think that's about it to give you an idea of kind of how to go about doing this stuff. Don't copy my design, but use this as an idea for how you can sort of help your workflow. Okay.